When summer pollution blankets a major metropolis like Delhi, the threat is heavy, opaque, and impossible to ignore. You can practically taste the particulate matter in the air. Faced with these conditions, our first instinct is to find shelter. We head indoors, lock the doors, shut the windows tight, and run the air conditioning to create a refuge from the heat. We prioritize thermal comfort. When we feel that sudden icy drop in temperature, we instinctively assume we are breathing fresh, pure air. But that perfectly chilled bedroom has actually become a sealed vault, trapping you inside with a suffocating, invisible reality. Indoor particulate matter, or PM 2.5, is actively generated every time we cook, use a cleaning solution, or sit on furniture that continuously off-gases chemicals. When we seal a room to maximize the AC's cooling efficiency, these biological and chemical contaminants have nowhere to escape. Then there is the carbon dioxide. As we sit in a hermetically sealed space, the CO2 we exhale begins a steady, unbroken accumulation. In our attempt to escape the outdoor air, we have turned our living spaces into closed-loop environments that trap our own pollutants inside. The hardware mounted on our walls is simply not designed to fix this. A standard split air conditioner operates on a closed mechanical loop. It draws in the existing air in your room, passes it over a refrigerated coil, and recycles the same air back into the living space. The built-in filter is a coarse mesh meant to protect the machine's internal parts from large hair and dust. It does not stop PM 2.5 particles, which pass through the mesh and back into your lungs. Even modern AC units marketed with PM 2.5 filters fail to address the core problem, as they still refuse to introduce fresh outdoor air. The contaminants simply continue to circulate. Cooling a room changes the temperature of the air, but does nothing to replace it. The limitation of the closed loop is most evident in the buildup of invisible gases that no standard filter can remove, specifically carbon dioxide. Sleeping in a sealed, air-conditioned bedroom means 8 hours of human respiration is flooding a constrained space with CO2. This data shows the rapid decline of air quality overnight. A sealed bedroom's CO2 levels climb from a normal baseline, cross the warning threshold, and reach levels as high as 2,500 parts per million by morning. This explains the morning grogginess, the lingering daily headaches, and the poor sleep quality despite a perfectly cooled room. Relying solely on an air conditioner creates a comfortable temperature while simultaneously degrading our cognitive focus and rest. Solving this requires separating temperature control from air purification. Safe indoor air requires a two-part approach. You need medical-grade HEPA filtration to capture the PM 2.5, paired with active ventilation to flush out the CO2. A positive pressure fresh air system pulls in outdoor air, sanitizes it, and builds a high-pressure zone inside. This pressure forces the stale air out through the microscopic gaps in your door and window frames. Effective air cleaning is an active exchange process. It is the functional opposite of an AC's closed-loop recirculation. The AQI0 whole home system was engineered for this specific environment. It is designed to maintain indoor PM 2.5 under 10 micrograms per cubic meter, while keeping CO2 levels below the 1,000 ppm threshold. This system operates alongside your existing AC, managing the air's purity without interfering with the cooling. The air conditioner was built to cool the air. The AQI0 handles the purification. By recognizing the difference between temperature and purity, you can finally have a room that is both cold and breathable.